Hello and welcome back to Math with Mrs. Becker. This is Pre-Calculus. Today we are looking at the second part of Chapter 1, Section 3, which pertains to arithmetic sequences. It is sometimes necessary to find the sum. Remember, the sum is your solution when you are adding. So it is sometimes necessary to find the sum of various terms in a sequence. For instance, we might want to find the sum of the first 9 terms of the sequence U sub n. Mathematicians often use the capital Greek letter sigma to abbreviate such a sum as follows. And so this is what the notation looks like. So we have the Greek letter sigma. Now this represents what term number you want to start with. So here we're starting with the first term. This is where we end. So we want to add up together. We want to find the sum of the first 9 terms, starting with 1, and you go all the way down and through 9. So for any positive integer, we can use sigma. We have any arithmetic sequence. This is the value you're starting with. So I'm starting with a 1. The last value you find is whatever value's on the top. You add those together. So let's go ahead and do this. So part of this is going to be making our calculations as well. So I want to find the sum of all of the numbers of this sequence. Remember, this is an explicit sequence because I have an n, not a u sub n minus 1. So I can just put in a 1 to find the first term, put in a 2 to find the second term. So if I want to find the first term, I'd have negative 7 plus 3 times 1. Well, 3 times 1 is 3. Negative 7 plus 3 is negative 4. There's the first term. Now we have to work all the way up to 5. 2 times 3 is 6. Negative 7 plus 6 is negative 1. Now we put in a 3. 3 times 3 is 9, because remember you multiply first. 3 times 3 is 9. Negative 7 plus 9 is 2. Now I put in a 4. 3 times 4 is 12. Negative 7 plus 12 is 5. Last but certainly not least, we reached our top value, which is a 5. 3 times 5 is 15. Negative 7 plus 15 is 8. So what I'm doing is I want to find the sum of these terms. So negative 4 plus negative 1 plus 2 plus 5 plus 8. If I add those values together, the sum is 10. So another cool thing that we can do with our sequences. Kind of fun. Let's look at another one. Now, to me, this is just set up in that explicit form. I don't like to leave it this way because it just appears to be more work than it needs to be. So the first thing that I do is I go ahead and I distribute the 4. So I have negative 3 plus 4 times n is 4n minus 4 times 1 is 4. So I look at this as 4n. Negative 3 plus a negative 4 is negative 7. To me, this is a little bit easier to work with. It's not so many different things to look at as you're doing your calculations. Okay, so it is okay to take something in this format and go ahead and simplify that down. We are starting with the first term and we are going up through the fourth term. This is sigma, so we're trying to find the sum. If I have 4 times 1 minus 7, 4 times 1 is 4. 4 minus 7 is negative 3. 4 times 2 minus 7. 4 times 2 is 8. 8 minus 7 is 1. 4 times 3 minus 7. 4 times 3 is 12. 12 minus 7 is 5. 4 times 4 minus 7. 4 times 4 is 16. 16 minus 7 is 9. So here are my terms, 1, 2, 3, 4. Now you add them. Negative 3 plus 1 plus 5 plus 9. My value, my sum, ends up being a 12. So that is the sum of a sequence. It says, suppose that we have a sequence. okay? And k is a positive integer. K is the value on the top. The sum of the first k terms of the sequence is called the kth partial sum of the sequence. It's such a weird thing. If U sub n is an arithmetic sequence and you know the common difference d, then for each positive integer k, the partial sum can be found using either of the following formulas. So here's the cool thing. There is a mathematical proof on page 27 of your pre-calculus textbook. And they are showing you not only how they came up with these equations, but how they are actually equivalent to one another. So the cool thing is, you can pick which one you prefer to use. For me, I always go to this one. I don't mind this one at all. So it's starting at 1 up to whatever value. So it's the top number divided by 2. That goes out front. Then in parentheses, because you have to multiply, the first term plus the last term. You add those together, multiply it by whatever k over 2 is, and you're done. Now this one works. It's the top term times the first term, plus take the top term times top term minus 1, that value divided by 2, and then you multiply it by the common difference. You will get the same solution. I like this one, so when we go through the notes, I'm going to use that. However, if you want to give the other one a shot and see if you like it better, you go for it, okay? Let's go ahead and try this. Find the 12th partial sum of the arithmetic sequence. So what that 12 means, that 12, that's the number that goes on the top. So I'm starting with 1 and going to 12. Okay, so that is what that means for my sequence. So the top number divided by 2 is how I start out. Now it's the first term. The first term, well, there we go. It's negative 8 plus, we got to be able to figure out the 12th term. Well, yesterday we figured out how to make that equation. So to go from one term to the next, I'm adding 5, I'm adding 5, I'm adding 5. So I can take the first term, negative 8, plus n minus 1 times the common difference. Distribute the 5, so negative 8 plus 5 times n is 5n, minus 5 times 1 is 5. So my formula is 5n. Negative 8 minus 5 more is a negative 13. This is the formula that I can use to find any term in that sequence at all. I need the 12th term. So 5 times 12 minus 13. 5 times 12 is 60. 60 minus 13 is 47. So here's what I did. They want the 12th partial sum, it means go from 1 to 12, of my sequence. I'm using the formula right here. Top number divided by 2, in parentheses, first term plus the kth term. And in this case, it's a 12. So I have 12 over 2. In parentheses, the first term is negative 8. I found my common difference. I formed an explicit formula so I could go ahead and find the 12th term. 5 times 12 is 60, minus the 13 is 47. So now I can go ahead and calculate. 12 divided by 2 is 6. Negative 8 plus 47, I end up with 39. If you multiply 6 times 39, the sum of the first 12 terms is 234. My 3 looked a little funky, that's why I rewrote it. 234. Okay, here's another one. Find the 14th partial sum. So what that means is I'm starting at 1, I'm ending at 14, and I'm trying to find the sum of a sequence. So it's 14 divided by 2. In parentheses, it's the first term, plus now I need to find the 14th term. To go from one term to the next, 21 to 15, I minus 6. 15 to 9, I minus 6. 9 to 3, I minus 6. So I know my common difference. So it's the first term plus n minus 1 times the common difference. Distribute. So 21 plus negative 6 times n is a negative 6n. Negative 6 times a negative 1 is a positive 6. So my formula is negative 6n. 21 plus 6 is 27. I need to find the 14th term. So if I go ahead and I calculate this, I have negative 6 times 14 plus 27, my 14th term is negative 57. Now we just calculate this. 14 divided by 2 is 7. 21 plus a negative 57 is negative 36. 7 times negative 36 is negative 252. So that means if I actually continued this pattern and I wrote out the first 14 terms and I added them together, this is what I would end up with. Okay, real life examples. Why do I need to know this? If the starting salary for a job, and we looked at a problem just like this the other day, if the starting salary for a job is $20,000, so that's what you get the first year, and you get a $2,000 raise at the beginning of each subsequent year. So your first year is $20,000. Your second year, you're $22,000. Your third year, you're $24,000. Okay, so that's what's going on. How much will you earn during the first 10 years? So let's say that you actually don't need this money. You are working because you think it's fun. So you take all the money you make, and we'll just say taxes are not coming out. Okay, we're going right with our $20,000, and you put it into a savings account. For 10 years, you don't touch it. We want to know how much money you actually made. This is so fun. So I'm looking for the sum. I'm starting with my first year of work all the way up to 10 years of the sequence. So it's 10 divided by 2. Your first term, 20,000. Plus, now we need to find out how much did you make just the 10th year. And that's a question here to make sure that if you were to get stuck when you read the direction, it's kind of a little hint. Well, you need to figure out what you make in that 10th year. Okay, so first year plus n minus 1 times your common difference. Your common difference is 2,000 because that's how much additional you make every year. Distribute 20,000 plus 2,000n minus 2,000. So I have 2,000n plus 18,000. So if I want to find out how much money I would make the 10th year, and that's just for the 1 year, that's not the sum. So 2,000 times 10 plus $18,000, your 10th year, your pay is $38,000. Now to find out how much you actually made, so remember our scenario. You're making this amount free and clear, okay? That's how much money you're getting paid. You are putting it aside. 10 years later, you're like, I wonder how much is in that account. This is what we'd have. 10 divided by 2 is 5. If I have 20,000 plus 38,000, we have 58,000. Multiply 58,000 by 5. In that account, you would have $290,000. So that's how much money you made during the first 10 years of that job. So cool. Okay, so this was a fun one where you're making money. Let's say you're a business owner and you want to figure out how much you're spending on something like maybe, in this case, advertising. It says Larry owns an automobile dealership. He spends $18,000 on advertising during the first year. That's a lot. That's like billboards and radio ads and TV commercials and all of those things. So $18,000 during the first year. He wants to increase his advertising expenses. He wants to spend another $1,400 every year. He wants to make sure everybody knows about his automobile dealership. How much will Larry spend on advertising in his first 9 years of business? So he wants to figure, okay, if I do this at the end of 9 years, how much of my money did I actually spend for advertising? And again, just as a little hint, how much, oh, perfect, never mind. I thought I did this again. How much would it be just during the 9th year? Okay, let's go ahead and it's 9 divided by 2, the first term. The first term he wants to spend $18,000. Plus, now we need to find the 9th term. So I have to make my equation. First term plus n minus 1 times your common difference. The common difference is 1,400 because that's how much more he wants to spend every year. Distribute 18,000 plus 1,400n minus 1,400. Combine your like terms. 1,400n, 18,000 minus 1,400 we have 16,600. If I want to find out how much he spent in the 9th year, I need to replace the n with a 9. So if I go ahead and calculate this, 1,400 times n plus 16,600, holy, so the 9th year just by itself, on year 9, Larry is spending $29,200 on his advertising. So to find the sum, how much did he spend total during the first 9 years? 9 divided by 2 is 4.5. 18,000 plus 29,200 is $47,200. If I multiply that by 4.5, in 9 years, Larry spent $212,400 on advertising. So my friends, that is sums. That is finding the sum of a sequence using sigma. Today's assignment is a book assignment. Tomorrow is a notebook check. I did kind of skip around just so you can practice a little bit of every type of questions. So you're going to look at 7 to 17, just the odds. Then go ahead 31 to 34. Try all of those. 39 and 41. There is only 12 questions total. Tomorrow there is a quick quiz just over what we covered today. I hope you had a great time. I'll talk to you tomorrow.